Hi everyone, dear children. In the last two videos, we discussed about Euclid division algorithm and its applications in exercise 1.1, and then we entered into exercise 1.2 based upon fundamental theorem of arithmetic. Fundamental theorem of arithmetic. So, based upon this concept, we can solve exercise 1.2. So, from this exercise, we will get 1 mark question, 2 mark questions in the public examination point of view. Most of the times they ask the questions from this exercise. So, please focus on this one. Clear? Is my voice clear? Right. Now, what this fundamental theorem of arithmetic theorem is telling us? Every composite number can be expressed as product of primes in a unique manner. Every composite number can be expressed as product of primes in unique manner. What is the meaning of that one? Composite number means which is having more than two factors is called composite number. Am I clear? For example, 4 is there. 4 is having 1 as the compulsory factor, 2 as a factor, 4 as compulsory factor. Okay. Right? So, if you observe that 1 is the factor of every number and the number itself is a factor of every number, these two are compulsory factors for every natural number. Other than these two, if there exists any extra factor, automatically that will be called as composite number. Likewise, if a number is having only these two factors, only 1 and itself, 1 and itself, these two only the factors, then that number is called prime number. Those are 2, 3, 5, 7, 11 and so on. These are the primes. All these numbers are having 1 and itself, the number itself as the factor. So, these are prime numbers. If there exists any extra factor than these, that is called as composite number. Such kind of all composite numbers can be written as product of their respective primes, but that number can be written in the unique manner. Every individual number can be written as in its unique pattern of product of primes. For example, let us take a number 24. 24, if you prime factorize, it will become 2 power 3 into 3 power 1. 8 3s are 24. Clear? In the same way, if you have taken 18 if you prime factorize, this will become 2 times of 3 square. Okay, Nana. So, 24 is a number, composite number. After prime factorization, like this. If at all you have any doubt, so I will do that prime factorization also, helpful for you. So, prime factorization means using the prime numbers we have to divide, we have to do the division continuously. 2 is the first even prime which we can divide it. So, then it remains 12. Again even number, that is why take even prime 2, it is 6. Again it is even, that is why take even prime 2, that is why it will become 3. So, 3 is the prime number, individual prime number. We can stop the prime factorization or you can take 3 as the division, so ends with 1. This is the ending process. So, 24 can be written as 2 into 2 into 2 into 3, which is nothing but 2 power 3 into 3 power 1. As well, if we take 18, even number, 2 9s are, again it is odd number, so 2 is not useful for us. Now we can go for 3 times 3, again 3 1s are. So, now 18 can be written as 2 power 1 into 3 square. So here you see 24 is a composite number. It is equal to product of primes in unique pattern. 24 can be written in this only one procedure. We cannot write 24 as the product of primes in any other manner. 18 also, it is equal to product of primes in this unique pattern. There are no other chances. If you observe this, 24 is having 2, 3 as the primes, 18 is also having 2, 3 as the primes, but their respective powers are different. So even though the numbers are taking the same prime numbers, but they have their own individual powers. That's why uniqueness will come for every composite number. This is about fundamental theorem of arithmetic. So take any composite number, you can write it as product of primes. Prime factorization process is this one. Okay, right. Now already I told you prime number is having only two factors, 1 and itself. These are the examples. Composite numbers are having more than two factors, 1, the number itself, and some other numbers. Okay, composite numbers. Here one important point we have to remember along with this prime and composite number, that one is, you observe that first natural number 1. Remember this one, very important. 1 is the first natural number which is not prime, not composite. 1 is neither prime nor composite. Remember this one. Okay, right. After discussing the fundamental theorem of arithmetic statement and some examples, what we have to take is, we should have to utilize them for, just a minute. Right. After discussing the fundamental theorem of arithmetic, we will apply this concept in prime factorizing the numbers. By this we can find out LCM and HCF of any two positive integers. Okay, fundamental theorem of arithmetic is going to apply to find out the HCF and LCM of any positive integers, maybe 2 or 3. Already HCF of any two positive integers can be found out by using Euclid's division algorithm. Okay, in the same way there is another process, that one applying fundamental theorem of arithmetic to find out HCF and LCM of any positive integers. What is that one? So to do this, what rule is there to find out the HCF? HCF of any positive integers will be traced out using the rule, that one is, HCF is nothing but product of, observe this one, product of common primes with their least powers, Have you understood this, Nana? Remember this rule. HCF of any positive integers will be calculated with this rule. What is that one? Product of their common primes. How to consider? With their least powers. If the common prime is having different powers in different conditions, choose their least power to calculate HCF. In the same way, the rule to find out LCM is same, product of all primes. Have you understood that? All primes with their biggest powers or highest powers. Okay, LCM can be calculated by doing the product of all primes with their highest powers, whereas HCF will become product of common primes only and with least powers. So in general HCF will become less than or equal to the given numbers, LCM will become bigger number, bigger or equal to the given numbers. Okay na, remember that one. Now let us discuss with one example. So directly we can take exercise 1.2 also, which is having very simple problems. Exercise 1.2 I am taking. Okay Nana, in this the most important problems are second bit, first problem, and fourth question and fifth question. Just these are most important in the examination point of view. Right, coming to this second bit, what they are telling is the question is find the LCM and HCF of the following integers by the prime factorization method. By using prime factorization method, find the LCM and HCF of the following numbers. What numbers they had given? 12 comma 15 comma 21, 12, 15 and 21. These are the numbers. Clear Nana? How to find out? Very simple process. Solution, write in detail, very neatly we have to write, because we have to impress the evaluator with our presentation. Right, given numbers are 12 comma 15 and 21. Okay Nana? Now find out their prime factorization procedures. 12 is coming under prime factorization. 2 6 are 2 3s are, therefore 12 can be written as 2 power 2 into 3 power 1. Okay, in the same way take 15, prime factorization, 3 5s are, that's it, both are prime numbers. So 15 is equal to 3 power 1 into 5 power 1. This is its prime factorization representation. And the third number is 21. 3 times 7 is 21. Both are prime numbers. Process stops. Now 21 is equal to 3 power 1 into 7 power 1. Am I clear? These are the prime factorization representation of each individual. Then what we need to find out? We need to find out the HCF. What is HCF? Write the rule, compulsory. In the exam you write in detail, product of common primes with least powers. Am I clear? We have to remember this one. So this is equal to, observe what are the common primes in this representation. 2 is the prime with some power, 3 is the prime with some power. Here 3 5 are the primes, here 3 7 are the primes. Among the three numbers, the common prime is very clearly, it is 3. Is that clear? Right. So now choose that common prime. But what is its power? It is having, it has to take least power, that is 1. Here power 1, here power 1. Luckily all are same. Even though if they are having different powers, choose the least power for HCF case. So least power 1, that is equal to 3. Therefore conclusion, HCF of 12 comma 15 and 21 is equal to 3. Right. Now coming to the LCM. Have understood this? Write in detail, nothing. Now LCM is equal to product of all primes with highest powers, with their highest powers. Means what? That is equal to, what are the all primes? 2 is a prime, 3 is a prime, 5 is a prime, 7 is a prime. write all the primes and take their highest powers. Okay, now 2 highest power only one time is existing, it is 2 power 2 into 3 is highest power 1, 5's highest power 1 and 7's highest power 1. If there are different powers, choose their highest powers. So take the product of all primes with the highest powers and do the calculation. This is equal to 4 into 3 into 5 into 7. This is equal to 3 7s are 21 times 20. This is equal to 42, 420. Therefore, LCM of 12, 15 and 21 is equal to 420. Okay, na? Right. Now, once again, you please observe that what are the given three numbers 12, 15, 21. By doing prime factorization according to their representation, HCF is calculating by applying the rule, we got it as 3. This HCF is less than all the numbers, sometimes may be equal to the least number. And HCF, we applied the rule and we calculated all the primes with the highest powers. After the calculation, we got it as 420, right? So now the HCF is bigger than the given numbers. Sometimes it will become equal to the bigger number. Okay, right. This is the first simple important problem from exercise 1.2. Have you understood this? Next, we will go for the fourth question. This one is this problem. Fourth and fifth problems are very important. Almost in all public examination papers, either in March or in June, almost all the papers contains this problem. Okay, na? Regarding composite number verification. Okay, Nana? Right. If you observe that fourth question, very important questions only I am explaining. The question is, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite number. They are asking to explain why the first problem 7 into 11 into 13 plus 13 is a composite number. Let us observe. Second problem we will do it later. Solution. Consider 7 into 11 into 13 plus 13. This is a given number. If you observe that 7 into 11 into 13, this is product of some numbers. Product of so many terms will become monomial. Single term will be treated as single term with product and division. With multiplication and division of any number of terms will be treated as monomial, single term. The second term, next term starts with either with plus symbol or with minus symbol. Have you understood that? So this total is single term, first term, plus is there here. So second term starts from here. So among this first and second terms, 13 is common. Now observe that one. If there is a chance to take any number common from the given mathematical statement, automatically that will become composite. Coming a number common will becomes composite number. So here 13 is coming common out of the numbers. Then this is 7 into 11 plus 1. So I can write this one as 13 into whatever this number may be. It may be a simple number or bigger number. It will become some m. It is 13 multiple. Prime numbers multiple 13 into m. Therefore, it has 1 as the total value, has 1 as the factor, common number, common taken number 13 as the factor, remaining product m as the factor, and there may chance to exist some other. So 1 is compulsory, common taking number 13 compulsory and its product m is compulsory factors. Clearly it is having more than 2 factors, that's why it is composite. Since it has more than 2 factors, it is composite, that's it. So once again I am explaining, if there is a chance to take a number common, that's it, it is a composite number. Common number giving us composite number form, because 1 is the compulsory factor, that common number is a factor, remaining its product is a factor. Clearly we are getting more than 2 factors, that's why it will become composite. Now come for the second problem in it. Second problem is given 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Already I told you, product of any number of terms will become monomial, first term, plus is coming here, starts second term. So among all these we can take 5 common, 5 is common. Then remaining value, after taking 5 common, remaining value 5 into 6 into 4 into 3 into 2 into 1 plus 1. This is equal to 5 into, you no need to waste your time, whatever the small value that it may be or big value it may be, take it as m, that's it. Therefore 1 comma 5 comma m are the factors, therefore it is a composite number, it is a composite number. In the exam you can write like this, okay Nana? So very important problems these two, right? Next one, fifth one, model is same Nana. What that fifth question is telling? Dear children, please observe that here I am trying to give this content only to reach the concept only. Here I am not going to use any technical highness in this aspect, only content I would like to deliver you. So with clear explanation I am trying to giving that one. So please try to encourage me. The fifth question here it is. The problem is saying, how will you show that 7 into 11 into 2 plus 7 into 11 into 5 is a composite number? Explain. Okay, right. Solution: 7 into 11 into 17 into 11 into 2, 17 into 11 into 2 plus 17 into 11 into 5, 17 into 11 into 5. This is the given number. Solution: given 17 into 11 into 2 plus 17 into 11 into 5 can be written as, just think about it, this is first term, plus is coming, so from here onward second term starts. From these two terms, is there any chance to take a number common? Very clearly it is visible that 17 is common, 11 is common, so consider them and take them common. Remaining value 2 plus 5. This is equal to 17 into 11 into this bracket value I used to take it as m, already I told you na. Therefore it has one compulsory factor for every number, 17, 11, m and so on as the factors. Is that clear to you? Very simply. Therefore it has more than 2 factors. If a number is having more than 2 factors, therefore it is a composite number. Okay Nana? They are asking to explain, so we have to give the explanation. So without giving proper explanation, if you conclude the answer, they will try to cut half marks, 1 marks, depends upon the weightage of the problem. Okay, so don't give the chance to the evaluator, just impress them with your presentation. Okay, now these are the most important problems from exercise 1.2, which is very simple. Listen Anna, already I told you, in Telangana and in CBSE we are following CC pattern. CC pattern means no question will be there from textbook directly in the public examination, but model questions will come most of the times. Okay, so based upon these 3 problems, I will try to give some extra problems. You try to solve them by your own. Extra problems. First one, find the HCF and LCM of first one 18, 16 and 30. And one more question, second one 14, 20, 42. Find their HCF and LCM. And one more extra problem based upon this, you just observe this, 13 into 15 into 17 plus 10 is 13 into 15 into 17 plus 10 a composite. Is it a composite? Explain. That is common. Explain. Okay. One more question. Third one. 10 into 11 into 12 plus 18 into 19. Is this a composite? Explain. That's it. Like that with numerical changes, if we are habituated to practice some extra problems after every exercise, automatically under CC pattern we will get perfection for the public examination point of view. Okay Nana, so winning in the final is nothing but winning the matches from the league level. Okay na, right? So like that, after the completion of every exercise, I will try to give some numerical changes extra problems. You please try to solve them. Right Nana? Thank you. Have a good day.